A precipitation reaction is a reaction in which two aqueous solutions are put together and a solid is formed. So essentially what you have is reactants that are soluble in water, and then you make a product that is not soluble in water, so out it comes. Let me give you an example of a precipitation reaction. Sodium phosphate, aqueous, plus barium nitrate, aqueous, yields sodium nitrate, aqueous, plus barium phosphate, solid. Now, in terms of what things are aqueous and what things are not, there are rules that I will give you that you can memorize. Essentially, you really have to know only two. One is that ionic compounds with +1 ions are aqueous. So, compounds with sodium ions, compounds with lithium, potassium, ammonium, all of those things are aqueous. So hence, sodium phosphate here is aqueous. Sodium nitrate here is aqueous. The other rule is nitrates. Anything with a nitrate is aqueous. Those two rules will pretty much get you anywhere. Compounds with +1 ions, aqueous. Compounds with nitrates, aqueous. Always. So the pattern for a precipitation reaction is two aqueous reactants. Then the products are one thing that's aqueous and one thing that's solid. Now, when we write a net ionic equation for this reaction, remember that anything aqueous is going to break apart into its ions. There are 6 sodium plus ions, aqueous ions, in the reactants. 2 phosphate ions. 3 barium ions. And 6 nitrate ions. All aqueous. So they're all ions, so I've written them all with a charge. Those are all on the reactant side. On the product side, I still have 6 sodium ions, 6 nitrate ions, and I have the solid barium phosphate, which does not break apart into ions because it's sitting as a solid in the bottom of the beaker. It's not dissolved in the water as aqueous ions. Now, remember that a net ionic equation is only concerned with what is changing. So things that are not changing are going away. The 6 sodium ions, I'm not going to bother writing it in my equation. They're still there, but I'm ignoring them completely because they're not changing. 6 nitrate ions, not changing. They're being ignored. So the net ionic equation is what's left. 2 phosphate ions, 3 barium ions, yielding the solid barium phosphate. You'll notice it is balanced. It does not matter what order you put those ions in, as long as everything's on the correct side of the arrow.